Okay, so today we're going to move on to section 6.2, which is on radian conversions. Hopefully after 6.1 you're really comfortable with what a radian is. You know what I said comfortable? You're not supposed to be 100% comfortable just yet. You will be, hopefully by the end of this chapter. But you're getting better at it is what I'm hoping with the radians by this point. Today we're going to be going on, I do want to announce we will be having a quiz on Monday the 19th, and we're just kind of going over section 6.1 and 6.2, really kind of making sure that everybody's on track before we go away for our holiday weekend. So yesterday's assignment was here. If you have some questions, come and talk to me in person. Today, from this point, what we're looking at is we're looking at converting revolutions and radian measures. And so we're going to be using revolutions. We're going to be talking about a bunch of different things. And then we're also going to talk about linear and angular velocity and talking about some formulas for that. So let's just talk about this. We're doing some conversions. We're converting. You do this a lot in science, but here we're going to be talking about our conversions. And we want to talk about how many seconds we'll start with are in 1 minute. Well, hopefully you know there's 60 seconds in 1 minute. Hopefully you know that there's 60 minutes in 1 hour. Usually those are the easy ones. Well then, okay, what about seconds an hour? Well, 60 seconds times 60 minutes leads us to say there are 3,600 seconds in 1 hour. Remember, these are all a 1 here. Okay, now let's move on to a different form. Let's talk about length. How many inches in a foot? Well, there are 12 inches in that 1 foot. How many degrees are in a revolution? All right, actually one that I don't have here that I'm just realizing that I really should is how many feet are in a mile. A lot of times that comes up. And this is actually can be found in your planner. It can be found in a different parts. But you need to, at some point in your life, memorize or know how to have right at your fingertips 5,280 feet are in 1 mile. So that's something I needed to add to our list. All right, let's move on here. How many degrees are in a revolution? How many degrees are in a complete circle? Well, we should know that one by now. There are 360 degrees in a complete circle. Now with radians, we know that there are a pi radians is 180 degrees. So a complete circle would be like that 180 degrees and 180 degrees, or pi and another pi radians. So there are 2 pi radians in 1 revolution. The last thing we want to know is, hey, if we have a revolution, how do we figure the distance around that circle? Well, a complete revolution, the distance is we use this math term called circumference. So circumference and revolution are the same thing. They are equivalent words for us. And circumference formula, if you remember, the circumference is 2 times pi times the radius. So that's going to be helpful to know for some of our conversions. All right, well, you should have this note sheet. It was handed out in the hybrid class, and if not, it's on the Moodle site and you can print it out. You might want to pause this and make sure you have it in front of you, or you can recreate it, but it's kind of nicer to have the note sheet. And on the note sheet is just like some things we can just use to remind ourselves. So the first one is we are taking 2 revolutions per minute, and we want to, in the end, have it in degrees per second. All right, and how do we turn revolutions per minute into degrees per second? Okay, well, what we do is we take and we look at like one at a time. One at a time, meaning I want to first focus in on how can I turn revolutions into degrees. So that's all I'm going to focus on, is how can I turn this revolutions into degrees. So what I do is I'm going to do this, it's kind of a magic trick. I'm going to multiply by 1. All right, not just a 1. We can write 1 in a variety of ways, and multiplying by 1 is really, really powerful. So instead of just writing it as a 1, I'm going to write it as a variable or as a fraction where any number over itself. And the kind of magical part is it doesn't always have to be the same. It doesn't have to be something like 3 over 3. It just has to be 2 things that are equivalent. Now, remember back here where I asked you how many revolutions are in degrees, and we said these 2 are equivalent. 360 degrees are equivalent to 1 revolution. Well, that's powerful. If those 2 are equivalent, I can say one revolution, I'm going to just put ReV for revolution, is equivalent to 360 degrees, DEG for degrees. Therefore, I just wrote down here, I'm multiplying by a 1. So this is technically a 1 because it's the same value over itself, because 360 degrees and 1 revolution are the same thing. The power in this is that this revolution can reduce down with this word revolution, and I no longer have revolution. Now I have degrees, which is what I wanted. Okay, now I'm going to deal with how do we change the minutes into seconds. Okay, so it's like a whole new multiplying by 1, another multiplying by 1 here. Okay, minutes and seconds. Well, I hope you don't have to go back here and say, oh, there are 60 seconds in 1 minute. Hopefully you just have that in your bag of tricks. How do I know whether I go 60 seconds here and later on I put down here 1 minute? How do I know if it goes that way, or if I put the 1 minute out down here? How do I know? Well, what you actually think to yourself is, what do I, I get this all separate. Okay. Oh, that's not what I wanted. Sorry, guys. Sorry. All right, let's see. You stop it. There we go. All right, so I'm going to get my 1 minute. All right, so the reason I want the minutes in the numerator is that now I can reduce down these minutes with this minutes, and in the end I want my seconds in the denominator. So you can choose. I chose whether to put the minutes in the numerator or denominator. I chose to put it in the numerator. It just made sense because everything in the end is going to end up where I want it. So you get to choose. As long as what is in the numerator and what is in the denominator are equivalent, you are making an equivalent statement and just multiplying by 1. So now I need to get a handy dandy calculator, because on the calculator what I need to do is in the numerator I'm going to go 2 times 360. I'm not going to go on my calculator and times 1. I know how to do that. And then I'm going to divide it by 60, because again here it's like 1 times 60. 2 times 360 divided by 60 ends up to be 24. So my answer in the end was 24 degrees per second. All right, let's do another example. Hopefully you it's like this is one where notes was like, I just have to show you how to do it. There's not a good way to take notes without an example. So now we have 100 pi radians over 1 hour. And our goal in the end is to get how many revolutions is that per second. Okay, my first goal is to get radians into revolutions. All right, so again, is you just kind of decide. What do you want to start with? I'm going to focus in on radians and revolutions. So radians. All right, 100 pi radians. So I need to say how many radians is in 1 revolution. There are 2 pi radians in 1 revolution. Now remember, I chose where to put the radians and where to put the revolutions. I chose the revolutions in the numerator because I want it in the numerator in the end. I chose the radians in the denominator because that'll reduce down with this radians. Okay? Now I need to deal with the hours. Now they gave me 2 here because I think the idea was, well, 1 hour is 60 minutes, and then you can say 1 minute is 60 seconds. So that's why they gave me 2 spaces. I think if I was doing this, I probably would have said 1 hour is 3,600 seconds. And we figured that out in the slide before, but it's okay to take 2 times to work this out too. So you kind of have to make sure, did I get rid of everything? Yeah, my radians reduced out, my hours reduced out, my minutes reduced out, and I'm left with revolutions per second, which is what I wanted over here. Now it's just about, okay, multiply it out. So what I'm going to do to multiply it out, and I'll just do it over here, I'm going to take 100 times 3.14 for pi. I'm going to take that times nothing, times 1, which I don't need to multiply by on my calculator. I can do that. I'm going to divide it by, and be careful that you're dividing it by with a parenthesis. 2 times 3.14. Oh, I really didn't need to do 3.14 twice. I'm realizing I could have reduced my pi's right here. Let me do that. That'll make it easier for myself. I'm just figuring that out. So really now I can just go, I really have just 100 in my numerator, and my denominator is 2 times 60 times 60. 2 times 3,600. When I work all of that out, what I got 1 over 72. I don't love this answer that you kind of get a fraction. When you get the decimal for 1 over 72, and kind of, I don't think I'd care if you had the decimal or the answer. 1 over 72, I get 0. I don't like this answer at all. 0.013. Okay? So, it's just okay. I don't really love the answer. Okay? Let's look at number 3 now. 10 revolutions in how many minutes? Okay, I gotta get more space here. Excuse me. Oh, I gotta put that in. More space. All right, 10 revolutions, and I want to get to feet per second. All right. I have to figure out first, how do we get from revolutions to feet? And this is really important that they had to tell me this, that, oh, my radius is 120 inches. Because I have to remind myself that 1 revolution is really the circumference. Remember that? So if 1 revolution is the circumference, then 1 revolution is 2 times pi times the radius, which is 120 feet. So now that's where, or 120, ooh, I apologize. 120 inches. I don't even have space for that. All right, so we had 2 times pi times 120 inches, but we got rid of our revolutions here. Okay. I don't want inches, though. I want feet. So that's where I have to say, oh, that means 12 inches is 1 foot. Now I can get rid of my inches here. So now my inches go away. Okay, I have feet. Last thing is I need minutes into seconds. So I'm going to say 1 minute is 60 seconds. So 1 minute would be in the numerator. I want to get rid of that with the minute in the denominator that's there, is 60 seconds, and I wanted the seconds. So by doing that, this minute goes away. So my numerator is 10 times 2 times pi times 120. My denominator is really 12 times 60. All right, I can do that. I just go on the calculator. There we go. 10 times 2 is 20 times 3.14 times 120 divided by 12 times 60. And I get 10.5. So my answer is 10.5 feet per second. All right. So now let's do some word problems here for our note sheet. A merry-go-round is spinning at a rate of 1 revolution per second. How many degrees is it turning per minute? So we have 1 revolution per second. And keep our goal in mind. Our goal is degrees per minute. Let's start with revolution into degrees. Revolution into degrees. I know that 1 revolution is 360 degrees. Now we just need to turn seconds into minutes. I know that 60 seconds is 1 minute. Now I just need to multiply 360 times 60, and really that's my answer there. I get 21,600 degrees per minute. Now number 5. If a tire on a race car is traveling 1,500 revolutions per minute, and we know a diameter, let's think about that. In the end, we want miles per hour. All right, let's go to revolutions to miles. Remember that a revolution is a circumference. If this is the diameter, the radius must be 16 inches. So my revolution is really 2 times pi times 16 inches. I need to turn inches into feet. I know that 12 inches is 1 foot. Okay, I know that there are 5,280 feet in 1 mile because I had to have miles in the end. I am running out of space. That's okay. We will move it. Here we go. And then I know we have 1 more left. I have to turn minutes into hours. I know there are 60 minutes in 1 hour. Okay, HR. I just have to multiply across. I'm going to go 1,500 times 2 times pi times 16 times 60 divided by, don't forget to put parentheses around these 2 when you divide by them, 12 times 5,280 right there. What I got for an answer there was 142.7 miles per hour. Final answer. I'm going to have you work out this one on your own. See if you can get 28.8 radians per hour. Just made it under the wire. Good luck.